Okay, we're gonna tackle one of the deepest, most profound mysteries in all of science today. I'm talking about a question that really shakes the very foundation of our reality. It's this paradox that lives right at the heart of modern physics, and it's all about time. So let's just dive right in with the biggest question of all, right? Does time, that steady forward march of moments that governs our entire lives, does it actually exist as a fundamental part of the universe, or could it be something else entirely? Well, the thing is, the answer you get really depends on which physicist you ask. And here's why. It's because our two greatest theories of the universe, the two most successful ideas we've ever come up with, are at war with each other. It's a total clash of titans. And the battleground? It's the nature of time itself. So on one side, you've got Einstein's masterpiece, general relativity. That's the one that governs the big stuff. Planets, galaxies, the whole cosmos. And on the other side, you have the strange and powerful rules of quantum mechanics, which, runs the show for the tiny world of atoms and particles. The crazy part is, both of these theories are basically perfect in their own arenas. But when you ask them about time, they give you completely, wildly different answers. Yeah, and these two views couldn't be more different. See, in general relativity, time isn't just some background tick-tock. No, it's woven together with space to create this dynamic fabric, spacetime, that can be bent and warped by gravity. For Einstein, time is flexible, it's relative. But then you look at quantum mechanics, and it's the total opposite. Time there is like this absolute universal clock, a rigid ruler that just ticks away at the same rate for everyone, everywhere, no matter what. And, well, these two ideas just can't both be right. Something's got to give. So what happens when physicists try to smash these two theories together, to try and create that holy grail, a single theory of everything? Well, they run headfirst into a paradox so bizarre it suggests something absolutely shocking. That on the most fundamental level, the universe might not have any time at all. Okay, so one of the most famous attempts to actually do this is this monster of an equation. It's called the Wheeler-DeWitt equation. It was this bold, brilliant effort to write down a single formula that could describe the quantum state of the entire universe. But there was a ghost in the machine. Because when you actually solve the equation, the variable for time, the little letter t you see in pretty much every other physics equation, it just vanishes. Poof, it cancels itself out. And what you're left with is an equation that describes a static, completely frozen universe, a quantum reality where, deep down, nothing ever actually changes. And that is a huge problem, right? Because we all feel time passing. So how can our everyday reality be so different from what this fundamental equation is telling us? And the mystery just gets deeper when you look closer at quantum mechanics itself. So in the quantum world, basically every property you can measure, like a particle's position or its momentum, its energy, it has this special mathematical tool called an operator. You can think of it like asking a specific question. Hey, where are you? Or how much energy do you have? But here's the weird part. There's a huge glaring omission. There is no time operator. There's just no way to ask the quantum world, what time is it? And the reason why is just stunning. The legendary physicist Wolfgang Pauli actually proved that if you even tried to create a time operator and plug it into quantum mechanics, the consequences would be catastrophic. Like every single quantum system would become totally unstable. A simple hydrogen atom couldn't even exist in a stable state. So the very fact that matter is stable, the fact that the world around us doesn't just dissolve into chaos, is because time can't be treated like space in the quantum rulebook. It's literally forbidden. Okay, so this whole paradox has basically forced physicists to think way, way outside the box. They're considering this really radical new idea. What if time isn't fundamental at all? What if our entire experience of time passing is just an emergent property, something that bubbles up from a deeper, timeless reality, all powered by one of quantum mechanics' weirdest tricks, entanglement? So this is this idea of emergence, and it's a really cool concept. Think about it like this. The wetness of water isn't a property of a single H2O molecule, right? A single molecule isn't wet. Wetness is something that emerges when you get billions of them interacting. So the idea here is that time could be the same thing. It might not be a fundamental property of the universe itself, but instead it's a large-scale effect that just appears from all these quantum interactions happening way down at the smallest scale. And there's this brilliant model that shows how this could work, called the Page-Wootters mechanism. Okay, stick with me here. It goes like this. First, imagine the entire universe is in one single static quantum state. like a frozen photograph, just like that Wheeler-DeWitt equation told us. Now, imagine an observer inside that universe picks one small part of it to be their clock. Next, through quantum entanglement, that clock gets linked up with, well, everything else in the universe. And here's the kicker, the magic part. For that observer who's inside the system, as their little clock seems to tick, the rest of the universe appears to evolve along with it. They experience the flow of time, even though if you could step outside the whole system and look at it, it would be perfectly still and timeless. Time, in this view, is basically an inside job. It's a personal, internal experience. And what's so fascinating is that this super cutting-edge physics actually brings us full circle, right back to a huge philosophical debate from centuries ago. You had Newton on one side, saying time is this real, absolute container that everything happens inside of. But then his rival, Leibniz, argued that, no, time is just the relationship between events. It's just how we order them. And this new physics, it's strongly suggesting that Leibniz, he might have been onto something. So, where does all this leave us? Well, this whole idea that things we experience as fundamental might not be fundamental at all is pushing physics into some seriously mind-bending territory, because it's not just time that might be an illusion. Some of the latest theories, like the incredible AD/CFT correspondence, are now suggesting that the entire fabric of space-time, all of space and all of time, might also be emergent. That it could be like a projection bubbling up from a complex web of quantum information and entanglement that lives on some distant lower dimensional surface. Which brings us to this final, absolutely wild thought. If space-time itself is just an emergent property of quantum information, does that mean our entire three-dimensional universe is just a kind of hologram? A complex illusion projected from a more fundamental reality that has no space and no time? It's a question that physicists are still wrestling with today, and it just goes to show you that the simple act of looking at a clock might be hiding the deepest secret in the entire cosmos.